Hello everybody. Friends, I am starting my new channel on Python with the name Programming in Python with RSK. This is the first video I will be uploading in a few days time. Hope you will also support this programming channel on Python. My channel Programming in C with RSK shall continue to be updated with the new videos on different topics of C programming. The C programming's link, the channel's link is given here. Please subscribe to both of my channels. Now to start with Python. In this video, it is an introductory video. I will introduce certain features of the language Python. It was launched in 1991. That means around 35-40 years back. And it is created by Guido van Rossum. It is a free language. Its download is free, and its interpreter is available for most of the commonly used platforms like Windows, Linux, etc. The most useful feature of this language is a program developed for any platform can be ported to any other platform. It is a very useful feature. The source code for one platform, it can be simply copied and pasted to another platform, and it will get executed on the second or another platform without any modification in the source code. No change is required in the source code for its execution across platforms. There are 4 implementations of Python. They are called CPython, which is written in C. When we download the Python from its official website python.org, we get CPython on our downloads. There is another implementation called PyPy. It is written in RPython. The third implementation is JPython, which is for Java, and the fourth implementation is IronPython or IPython, which is in C#. We will see how Python script is converted to executable program. Python program or the script, that is the file with written Python source code, it is always saved with an extension .py. When we compile the program or when we execute the program for the first time, that script gets compiled in a compiler, Python compiler. Python compiler converts the source file into Python bytecode. That bytecode file is generally with the extension .pyc. All these 3 activities or 3 steps are platform independent. They are common for all the platforms. What changes with the platform is the program or the software called PVM, Python Virtual Machine. These PVMs are different for different platforms. There is a PVM for Windows, there is a PVM for Linux, there can be a PVM for any other platform which is under used by various users or is under development. This PVM is installed by default when we install Python on our machines. So if we install the Python on a Windows machine, the PVM for Windows and x86 86 variants of the microprocessor get installed on our machine. Similarly for Linux and for any other platform. How it differs from C, C++ compilers? In C compiler or C++ compiler, script file has an extension .cpp. There is a different compiler specific to every platform. There is a compiler for Windows and 86 combination. There is a compiler for Linux and XXX86 combination. There can be compilers for some other OS and microprocessor combinations. What these compilers do is they compile the program and convert the source file into machine code specific to the microprocessor and the combination of the OS. So compiler for Windows will convert the source file into machine code for 8086 variants of microprocessor. Similarly for Linux, similarly for other compilers. Whereas in Python, the compiler converts the whole the source file into a bytecode, and for each bytecode of each type or all the bytecodes that get converted can be executed by specific PVM for a particular combination of OS and microprocessor system. There are many features of Python, a few of which we will be discussing in this video slide. A very important feature is dynamic typing. When we type a program using the Python IDE, it is not necessary or it is not at all required to declare a variable's data type. Data type is inferred from the context of use. Specifically in other languages, when we are going to use a variable, we first have to declare it along with its data type. That is not necessary in Python. Python captures the data type with the or deduces it or infers it from the context of use. In most of the languages, memory allocation has to be done programmatically, and also the garbage collection. Whereas in Python, all these activities are automatic. We need not provide the functions for these activities of memory allocation and garbage collection in our programs. Python has basic data types: int, float, complex, bool, and bytes. What we can see here is, as in C or C++, there is another data type which is called char, C-H-A-R. That data type is not available or is not required in the Python while programming our application. There are other data types which are very powerful entities which are called collections. List, dictionary, tuple, string, set are all container data types. It makes the program development fast and easy. There are another data types, specifically the classes. The class is declared as a user defined data type. When we declare a class, it becomes a user defined data type. The advantage of creating classes in our program is reusability of the code. So once a class is created, that class can be included in any other program, not in that particular specific program, so that all its functionalities are available for all the programs we shall develop in future on Python. Advantages, some more. The interpreter finds out the data type through the context in which it is used in the program. As we have seen in the previous slide, there are many third-party libraries which are available for website construction, games development, machine learning, numeric and scientific programming. There are ready-made libraries. We have to just include those libraries in our program, and all the specific functions of that library are made available for development of our program. Then there are many built-in commands which we will see later on in the subsequent videos. These commands mainly deal with search, slicing, sorting, concatenations, and many more. Python can be developed in any paradigm. Python program can be developed in using any paradigms. When we create a program for solution to a problem, there is one way that is called procedural programming, which is we are quite conversant with C programs. Procedural programming gives us a solution. Python provides for procedural programming. It also provides for functional programming. What is functional programming? It is built with a lot of functions in the main program, and those functions are defined somewhere else. Then we can develop a Python using object-oriented programming, which is basically a programming with the classes, and we can also develop event-driven programs using Python. What is event-driven? It is a program which doesn't execute unless user gives a particular command. In procedural programming, once we start the program, the whole statements of the program will get automatically executed till we reach the end of the program, and that end, when program terminates, it gives us the solution for our problem for which the program is developed. In event-driven programming, the user initiates whatever part of the program he desires to use. Well, the Windows is the best example for event-driven programming. We get a desktop on which there are various options available. We click on certain option and that option gives us the desired result, which is always a event initiated by clicking a mouse or using a keyboard. The biggest advantage of Python is a single program can be developed using multiple paradigms in it. So all the 4 paradigms we can use to develop one single program, so that we get optimum solution to the problem for which we are developing a application. As in any other programming language, identifiers are required. In Python, all variables, functions, classes has to be given some kind of a name. Suppose we declare we want a int variable, then what we do is we give it a name, any name, say A, B, C, X, Y, Z or whatever. These names are called identifiers. Same is the with functions. We name a function and that name is called an identifier which refers to that function for that particular program. Same is with classes. There are certain rules by which identifier names are to be created. The first rule is any identifier must start with an underscore or an alphabet. We cannot start an identifier name with a digit or any other special character except underscore. And identifier can be constructed or name can be created using alphabet, digits and underscore only. Now these identifiers, names of the identifiers A123 underscore A123, name underscore stud, Z underscore X, D1 are all valid identifiers because they are either starting with an alphabet or starting with an underscore. Now these are all invalid names. 123A, 1 underscore name, because they are not starting with a digit which is not allowed by the Python compiler. There is a character hash. This character we can use to comment out the text in our source file. So anything, any statement which follows hash is not an executable statement. It is a comment. Comments are useful to describe the function of a particular statement in a program, so that program becomes maintainable over the number of years or irrespective of the person using or maintaining that program. If a program is created by person X, then when that program or that executable or that source file is required to be maintained over a period of time for the requirement of the customers or consumers, another programmer may be looking into that issue of maintaining a program. For him, if the important states or statements or steps in the program, original program, are clearly written in the program itself, the program becomes quite maintainable. But these statements or these sentences or the statements which are not to be executed but only for supporting the maintenance of the program, such kind of statements or such kind of sentences written in the source file are written following the or are written with a hash as is first character in that sentence. When compiler sees hash, it doesn't compile that statement. Any program needs a function or a statement which will display the results or on the console, and also it needs the functions which seeks user inputs from the keyboard. And in Python, print and input are two functions which are very useful and which are widely used in the development of a program. These are built-in functions. Print output the contents written within the brackets to screen. So it is a output function. Input assign the values input by the user through keyboard to the variables. So when we seek some value, suppose we are writing a program for maintaining a bank ledger, then every transaction that a customer carries out has to be included in the ledger. So for getting these inputs, input functions can be used. When the program starts executing, and it reaches a statement where input appears, the program pauses. The program doesn't start executing after input. It pauses, and when the user inputs the values required by or asked for or required by that program and press the enter button in the keyboard, the halted program starts executing further till another input function is reached. So whenever there is an input function, program halts and it starts executing afterwards when the user inputs the required data and presses the enter button. Now this is a small program. A comma B is equal to input, enter two numbers. Then there is another function dot split. When this statement will be executed, enter two numbers will first appear on the screen on our console, prompting the user to enter the values. So in this program I have entered 1 and 2 as the two numbers which I want to assign to variables A and B. Then there is a step called A is equal to the step for typecasting the inputs. Look here, we have not given, or the Python doesn't expect us to mention the data type for these two variables named A and B. When an input function is used and the user inputs the data, that data is taken as a string by the Python program, and we intend that these two inputs should be of type int. So we write these statements: a is equal to int a, b is equal to int b. When print statement appears on the in the program, executes in the program, we ask the program to display the values for a and b. So here we get a display: a is equal to 1, b is equal to 2. Then we ask the program prompts the user to enter name. So we enter names as two names as a and b, some random name. This first input statement will output enter name. Then this I have given as the input for the program. That a name will get assigned to a variable called s in this program. That is, that name I have entered will be assigned to a variable s, and we make that variable s as a typecast it to a data type str, which stands for string in the Python paradigm. Then this print s will output the name of the variable. Then we ask for another name. S is equal to enter name. In this case, enter name will appear first on the console, against which I have entered the name, some random name BBB, etc. That we again assign to the same variable s, and then we output the name that has already been entered by the user, in this case me, with this statement print s. So this print statement will throw an output BB to console. Well, in this program, as I will explain later on, this str typecasting of the input is not required actually in the Python, because Python takes every input in the form of a str data or string data. So when it is already in the is taken as a string, we need not typecast it. It is just here I am explaining how typecasting has to be done. In this case, int a typecast is necessary, int b typecasting is necessary. This str typecasting is not necessary in Python. So a and b data type typecasting is necessary. Data type not necessary, as str is the default data for a input function. So when input function picks up the values entered by the user, those values are taken as, or those values are of type string str, type str. Input function accepts the data entered through keyboard as a string. Data entered by user need not be typecasted to desired variable type. Need to be typecasted to desired variable type. Another example program for input, which is an actual program which I ran on my machine. A is equal to input value for a, b is equal to input value for B, both typecasted as int. A is equal to int into the bracket input into the bracket a string asking user to input value for A, and same with the B. So when I executed this program, first input values for A was appearing on the string, so I entered 200 as a value. Then I entered 300 as a value for B, and this print statement displays the values assigned to these variables by this input function. So similarly, it is with float. Here we are inputting an int value, so we are typecasting the input as an int. Here in this particular case, I am entering a float value. So this program, again another program which with float I have displayed here. This float input, this input function causes enter percentage of marks, whatever is written in the bracket here, as output to the console. This is a prompt given by the program to the user to input the desired value. Then I entered 99 as the percentage of marks, and then print, then I gave an input statement, name of the student, asking user to put name of the student. S is equal to input name of the student. Now here you can see that it is not, the input statement is not following a data type. Here it is following int, here it is following int, here it is following float. Here there is no data type mentioned because a name is always a collection of characters which we call string, and it is denoted as str in the Python. Let us see what are different paradigms which we discussed earlier. Now this is a procedural programming example. What I have done is A is equal to this much, B is equal to this. These are the values assigned to A and B. You can see these are the same values I have entered. Just for example, this print A displays the value of A, print B displays the value of B. Then there is a function called type in Python. What it does is it outputs the data type of the variable, the name of which is mentioned in the parenthesis after type. And what we see the output from this is class int and class int. Actually all the variables in Python are the objects of the classes to which those variables belong. Here we have not mentioned what is the data type of A or B, but by the Python has inferred it as it is a integer we have assigned to A and B. So there is no need to mention data type, but it has inferred and given us the output as int, class int and class int. So any variable or is a object, any variable in Python is actually a class of that data type, and all the constants and the variables that are used for that particular data type are its objects, or its the objects of the class int, object of the class float, and so on. Then there is another function called id in Python. What we are trying to do here is print id A and print id B. These two statements will output the id of variable A and variable B. For the moment, we may consider it as the memory addresses for A and B, which is not true, but we can just, for our understanding, we can think it that these are the memory addresses. Actual, what are the implications, or what ID implies, that we will see later in this program, in this video. Another example of procedural programming, suppose we want sum, difference, multiplication, division of two variables. Then in a procedural programming model, what we do is declaration of the variables, say int a, b, sum, diff, mult, div, etc. The first step in our program will be declaration of the variables. Now this procedural programming is not actually a Python programming, because in Python we need not mention the data types of the variables which we are going to use. How we do it in Python, we will see in the next slide. Then the program will prompt user to input the values for A and B. Then statements for assigning the values of input by user to A and B. Then logic of and statements for calculations. Sum is equal to A plus B, and all these sum, difference, multiplication, division. Then statement for display of calculated values, and such as print into the values of A, B, etc., etc. And the program ends. When the program ends, all the values of the calculated values of the operations done on two variables A and B will be displayed on the console. In functional programming model, what we do is program logic is broken into a many small programs called functions. These are all independent of each other. These functions are called by the main program to implement the complete solution. Now in this case, let us see the earlier, when we saw the procedural programming, how we can, that procedural programming is equivalent to a functional programming. How we make a functional program which gives us the same result. Now this is the main program. A is equal to 0, B is equal to C, sum, and all these things. Then there is a function init vals into the bracket 10, 20, 30. Then another function cal sum. Second function cal mult. This calculate sum. Cal mult will calculate multiplication of these three values. Then division, cal division, and end of the main program. We are not putting any statement here for inputting the values by the user, that is done by functions. When we declare a function named initVals, statement which prompts user to enter values for ABC, statement to assign these values to ABC, and then there is a function calsum which gives us the result of A plus B plus C, and the same function outputs the result on our computer screens. In this way, a functional programming will work. In event-driven programming, the program execution is in response to the events initiated by the user. Actually, event-driven programming is a program which is controlled by the user. All other type of programs, whether it is procedural or functional or object-oriented, user don't have a control on every step of that program. The user can intervene in those programs only when a statement for inputting some values appears in the program. In event-driven programming, nothing happens till the user initiates an event through keyboard or through mouse. Program responds, an event-driven program responds to events such as keyboard hit, mouse moved, left button clicked, right button clicked on the mouse, and all other things. When a user clicks a left button on the mouse, then a particular function specifically built for responding to this event will execute. So that desired result the user intends to get by clicking a left mouse button will be obtained. In object-oriented programming, there are many user-defined classes or third-party classes which are used by the programmer to solve a problem. So this is all about introduction to Python. Thanks for watching. Please share, like and subscribe to this channel. Also visit my channel Programming in C with RSK. The ID of that channel is given here. I have uploaded more than 50 videos specifically on C programming. Your visits to these channels are most sought after by me, and I am thankful for visiting these channels. Thank you.